Okay, so hello everyone. You are welcome once again to today's lesson. In today's lesson, okay, we are going to continue from where we left off. Okay, on the lesson sequences and series, the relative math aspect of that. And remember in lesson one, this will be lesson two. In lesson one, we concentrated on sum to infinity, and we said that sum to infinity is basically for GPs. Okay, you don't have sum to infinity. It will not exist when you are dealing with an AP. So anytime you are asked to find sum to infinity, you should know that the sequence or series confronted will be that of a GP. That's the geometric progression or an exponential sequence. And even with exponential sequences, not all of them, okay, will have its sum to infinity to exist. And we said that the sum to infinity will exist when your common ratio, which is your R, okay, is between -1 and 1, meaning your absolute value of your R should be less than 1. Immediately it's greater than or equal to 1, it will not, okay, exist. You can't find a sum, or yes, a sum to infinity, what we also call the limiting sum, okay, as well. So here, your question again, Karen, ask your question again. So this was the assignment. Okay, and we are going to go through the outstanding issues after I've sent you the video. So let's look at the outstanding concerns.
My question was, when you get the value for R, let's say the 1/100, is it compulsory like to put it in the absolute value sign as part of your working?
Okay,
Even if
very
it's a
good.
working?
Very good. Okay, so this is it. Remember when we use the absolute value one, okay, we said that one, we use that one to determine whether the sum to infinity will be possible. So if it is possible, then we can go and find it. Is that clear? But here, we know from experience, anytime you are giving recurring decimal and you express it as what? A geometric series, which obviously once it's geometric series, then it means the sequence will also be a geometric sequence. So you are going to have a common ratio. So you should know that always, once you are dealing with a geometric series coming out of your recurring decimal, your R will satisfy the condition that will permit the sum to infinity to exist. So you don't even investigate. It's when you are investigating that you bring the absolute value to check whether, okay, it will satisfy the condition for it, okay, to exist. And I mean the sum to infinity. Karen, is your question well addressed?
Yes.
So with this one, we didn't need to investigate. However, if you per experience, you know that always your R, and this R here, okay, is positive, and you know that it's between or its absolute value, even mentally, you know that the absolute value is less than 1. So you don't even have to go and do the absolute value. It's not necessary. You don't perform that check because now you are experienced. So straight away you write this, then you go and substitute. The other one we didn't know, and because we realized that some of them, okay, some of the exponential equations, okay, will not have the sum to infinity to be possible to exist. So we do the test, and when you do the test and it's satisfied, that's when you can come and use the formula and substitute directly. So here it will satisfy, so you can use. Otherwise, okay, we can't quote the formula and use it. Safa.
Yes.
All right. Okay. So if that's the case, then let's move on to, okay, our next concept. Okay, our main business for the day. Okay, before I move on, any other, apart from Karen, okay, any other issues, concerns, okay, related to the assignment that I gave you? After watching the video, do you still have any issues from your solution that you sent to me, the concerns that I raised? If not addressed, bring it out. Otherwise, okay, we'll move on. Okay, so it means we are fine. So we are moving on. All right, so now to our main business for the day. We are going to look at the sigma or the summation notation. And this a notation that you are all familiar with, especially in JHS that you did, what do you call it? Yes, statistics. Because in statistics, definitely you'll be introduced to this. But quickly, let me read. Okay, this is a concise notation for sums. So meaning this is the notation that you use to compress sums. Okay, anytime you are summing numbers, forgive me, you are summing numbers. okay, you can use this notation to make your work very easy. I mean, for you to write less. So the notation is called sigma notation because it uses the uppercase Greek letter sigma written as, so this is the sigma notation. And you know, whenever in JHS you were told that if you are finding the mean, what is the formula for finding the mean? Okay, who knows the formula? What were you told? Make your JHS teachers proud. Okay, Abba, Mami Abba, Amamensa, Prof.
Please, sigma x over sigma, over n.
Over n, okay, all right. You could have used sigma fx also, depending. In any case, if you are going to use sigma f here, then this should have been sigma fx. So this is it for the mean. So I just wanted to know, or indirectly confirm that you know this notation. Okay, that is the sigma, and you were introduced to that. Okay, so, and it's the Greek letter. Okay, the small letter, this is the uppercase. The lowercase letter is written this way. Okay, so take note. Usually it is like this. Okay, but we write it this way for convenience sake. It's just like this. It's looking like this. That's how it looks. Okay, so take note. So the sum of the n terms. So here I'm using a sub 1, not our usual u sub 1, u sub 2. Okay, you can equally use that. Okay, that's it. I just want flexibility. That's all. Okay, so a sub 1. So my first term, my second term, my third term. So I have the sum of n terms. So I should have a sub n. So it means I have n terms, term 1 up to term n. Okay, the n term is written as, so this is how you can easily compress or write this for the sum. So I'm looking at a sub 1 plus a sub 2 plus a sub 3. This is what you have there, then plus your ellipses, then plus a sub n. Okay, so what you have here, this is how you write it. It will be the summation of a sub I. Okay, where your I, you will start from 1 and end at n. And if you can see the representation that we have here, indirectly, we are trying to say that the I here is the index. Oops, forgive me. Is the index, the I here represent the index of summation. Okay, there's the summation notation. We all know, I've stated that here. And the 1 is the lower limit of what your summation. So anytime you are summing, okay, you should have the lower limit and also the upper limit. And the upper limit is what? Always up here. So the lower limit will be down, the upper limit will be up. Okay, and the a sub I indirectly will be your formula for the u sub n, or in this case, a sub n, the formula for finding the n term. So it means here, you can see upper limit 1. So you start with 1 and you move on, okay, integer wise. So 1, you go to 2, you go to 3, up towards your n. So we are going to get exactly what you have here, okay, in the form that is stated there. So anytime you are summing, okay, numbers, we can always write it in the sigma or the summation notation form. And basically, that's what we are going to do, okay, today. So as our first concept. Okay, this is it, but let me go back. I think I can equally say, okay, whatever that I want to say here. Okay, so with this, let's write down the following as a series in 4 and simplify. So because you are looking at sum, okay, and you know, if you write it, it will be in terms of series because it's series that we sum the terms. Okay, and we know out of every series, we can generate the corresponding sequence. Okay, so we need to find, this is how we are going to read it, summation of n from 0 to 5, okay, of n. Summation, okay, of n from, okay, I can say summation of n from 0 to 5. I can read it this way. Summation of n from 0 to 5. So 0 will be your lower limit and 5 will be your upper limit. So that's another way of writing this. Instead of, I can also write it just as I introduced you to. I can write it this way, my n. Okay, then come and write n is equal to 0 just below 8 and the 5 on top here, just as you saw in the previous notation. Or I can bring the n, okay, here in terms of my limit here and here as well. Okay, so quickly, let's go and look at the meaning of what you have there. It's not difficult. Okay, so I won't even waste time on that. So quickly, as I walk you through the solution, you realize that it's not difficult, just substitution, that's all. Okay, so let's look at what is next. So solution. Okay, so solution. Oh, solution is already there, forgive me. Okay, so now what do? We are going to, okay, pick the question numbers, okay, and solve them. But before that, let's see whether after reading the question, we will get salient part to underline. So write down, okay, as a series in 4. So it means we have to write it in 4. We can't end anywhere. Simplify. It means all the terms must be stated before you simplify. So in this case, I come to A. A, what are we giving? And I've told you can choose not to write the given, but what will follow the given, you cannot choose not to. So you don't, it's not an option, you have to write it. So summation of what? N from 0 to what? To 5. And here you have your N. Okay, so in this case, this will be equal to, okay, your lower limit is 0, your upper limit is 5. So it means you have to substitute N is equal to 0. You move on to the next integer, 1 up to what? Up to 5. So that will give us the first one. If N is equal to 0, I'm going to get 0. Plus, if N is equal to 1, I will get 1. Plus, if N is equal to 2, I will get 2, because this will be 2. Plus, if N is equal to 3, I will get 3. Plus, N is equal to 4. Plus, okay, N is equal to 5. I will end there because I need to start from 0 value substitution for N and 5 value substitution for what? N. Is my point well made, my professors?
Yes, sir.
Okay,
Yes,
so
please.
at this point,
Yes,
the first part of the question, yes, please.
Sir, please, can you go over again? I'm finding it difficult to understand.
Okay, all right. You can see that you are summing, this is the meaning. You are summing N, okay, where N starts from 0 and end at what? 5. So it means if N is equal to 0, you substitute 0 here. You are starting from 0. Can you see that? Because this is the lower limit. Lower limit, you start from the 0 here and end at 5. So if N is equal to 0, then it means this will be 0. But now, because we are dealing with sum, when you substitute, that will give you a term. Then you come and write plus because you are going to deal with sum. So if you substitute your first value from your lower limit, you write the value, then plus, come and substitute the second. So you start from 0, 1, 2, 3, up to 5. That will be your order of substitution. Is it clear now?
Yes, please.
So if N is equal to 0, if you substitute it here, what will you get? If N is equal to 0, what will be here? I'm talking to you, my professor who said I should come again. If N is equal to 0, 0, okay, so it means we've dealt with the first substitution. So you write 0 there, and the sum, so plus, then the next one will be 1. If N is equal to 1, what will be here? It will be 1. You substitute directly, and that will be 1. You get it? So the next
Yes.
1, 2, 3, up to what? We'll do more, so don't worry, your understanding will be perfect. So the first part of the question dealt with. Now, the second part of the question, what do? We need to simplify. So we know that this will be equal to, okay, now we are going to add this. So it will be 3, 6, 10, 15. Do you agree?
Yes, please.
Okay,
Yes,
so
sir.
therefore, by summation, okay, of N, from N is equal to 0 to 5, okay, will be equal to 15. As simple as that. So far.
Yes, please.
Okay, so let's move on to the second one, if your understanding is not perfect. And please take note, okay, here, every line must be used. Every line must be used. So as you move from here to here, okay, it means the line here, if there is any line there unused, move. That should be your next line that you are supposed to use. Don't leave spaces between your steps. The new ones are doing that. That's why I'm reiterating that. So the old one, old students, old professors, okay, please, okay, bear with me. Okay, so B. So when you are moving from one sub question to another sub question, that's where you leave at least a line, maximum 2 lines, but 1 line will do. So here, that's where you leave a line. So this time around, I'm not going to, okay, write the given. Okay, so I'm looking at summation of R. Okay, so I'm for 2R. Okay, R starting from 2 and ending at what? 10. Okay, in actual fact, I could have put I didn't extract it the way it came, but that's the same meaning. You can see that the way it came, the R is equal to 2 is stated here. So you let me extract it the way it came so that you can equally do that. That's not to say, if you write it below here, this one below, then it means this one also should be on top of your sigma sign for consistency. So take note of that. So it means I have issues. So if I want to maintain that, then I have to write that one rather on top. Okay, take notes. So it means my 10 is supposed to be on top here. Otherwise, I write this one here and the 10 also here. So this will be equal to, and please, once again, okay, those of you, avoid writing more than 1 equal to on the same line. So this your step shouldn't be here. Okay, the last one, make sure you write your steps this way, column-wise rather than row-wise. Okay, so now this is what we are going to do. The first substitution for R, what value of R must we substitute here? Per what I've said so far. What should I substitute here? First value of R. That I need to substitute.
2.
2. And the last value of R that I need to substitute should be
10.
10, as simple as that. So it will be 2 from 2. Which value do you go to?
3.
3, 4, 5, up to what? Up to 10. So we are going to get 2. The first term will be 2 into what? Into 2. Then plus the second term will be 2 into 3. The third term will be 2 into 4. Please, are you with me?
Yes, sir.
Okay, plus the next term will be 2 into what? Into 5. Okay, then plus, can I write plus ellipsis, then come and write plus 2 into 10? Can I?
Yes, sir.
Do you say yes?
No, please.
Okay, why?
Sir, please, because the 5 times 2 give you 10.
No, I'm talking about another one, maybe plus. I don't want to write all the terms. So plus ellipsis, then I come and write the plus, the last one, which will give you 2. Okay, so maybe my 3 dots. Can I write this plus? Maybe 2 into the last R substitution, which will be what? 10. Can I write this? This is my question.
Yes, please.
Can I? Okay, I heard yes, I heard no. Okay, no. Why? Okay, Prof. Natalia.
I think you're working, so you should show every step of the
So
way.
I think the question said as a series in 4, so you have to show it.
It's okay. Very good. That was what I was expecting you. Exactly what I was. Before I started, remember I gave you that hint that because you are told to write it in 4, every term must be indicated. Other than you can see that this is not in 4 because you have some of the terms, okay, not catered for. Is my point well made?
Yes, please.
So that's the more reason why it's important to underline salient parts, okay, in the question so that we have our, what do you call it, marks fully protected. Okay, so you cannot write ellipses. Every term must be seen, must be indicated. Please take notes if you cherish marks, which I know you do. So you are going to write, so even if it was up to 100, we have no business to even leave one. We have to do all. Okay, so now we are at 5. Forgive me. So let's go. It will be 2 into 6, which will be our next term, then plus the next term will be 2 into 7, plus 2 into 8. Okay, plus 2 into 9. Okay, then plus 2 into 10. Is my point well made?
Yes, please.
Okay, so it's because of this that you can see that I didn't rule the line because I realized that in ruling the line, this will go through. Okay, so now this will be equal to, okay, you come and, okay, simplify each of the terms. So this will give us 4, plus this will give us 6, plus this will give us what, 8, plus that gives us what, 10, okay, 12, 14, okay, 16, okay, then plus, oh, what is happening? Give me some It seems my way is becoming too sensitive. Okay, forgive me. We'll clear that very soon. Let me restart my, okay. Okay, so now what are we going to get? Plus, oh, what is happening? It's still not resolved. Okay, plus, give me, technology sometimes can be like this, so pardon me. Okay, so let me, first of all, okay, pause, then rectify that.
Hey, Mr.
Okay, so now, this will give us 2 times 7, which will give us, so we've done 2 times 7, we've done 2 times 8, so we are now 2 times 9, okay, which will give us 18, okay, then, okay, plus 2 times 10, which is what, 20. So at this point, you just go and sum. But when you are summing, you know you land at your answer. So at that point, you can have your conclusion drawn, or you can even put therefore here. Okay, so this implies that, sorry, a summation of R equal to 2 to 10 of 2R will be equal to. Okay, anyone through with a sum already? I know by now.
108.
108.
Okay, so now we are done. Okay, so this will be it for this particular one. So I'm going to do maybe one more. Okay, and that will be fine for this particular one. The rest I will just, so let me see. Okay, so we have 3 more. Pick one. Okay, the one that we are supposed to do here. Which one do you want us to work on? Okay, so let's do E. Will E be okay for you?
Yes, please.
Okay,
Yes.
so as for C, I will just explain. So here it will be 1 squared as your first term, and put, anytime you are substituting, put your substitution in brackets. You know this. So it will be 1 in bracket squared plus 2 in bracket squared up to 9 in bracket squared. You get it?
Yes, sir.
And this one, then later you know how to deal with the squares, and you get your actual terms, then you add. Then this one too, it will be 2 to the power 0, okay, then plus 2 to the power 1 up to 2 to the power 5. Okay, so that explains that. So let's go for where we have more than a term. So E, straight away, let me see. So E, what are we giving? We are giving summation, oops. Okay, summation of R plus 2, R from 0 towards to 7. Okay, so this will be equal to, so here 2 terms. So your first substitution, R is 0. So it will be 0 plus 2. Plus your second substitution, R is what? It's 1. So 1 plus 2. Okay, then plus the next one will be 2 plus 2. I hope you are following my professors.
Yes.
Okay, up to, okay, 7 plus 2. So I just want something to come out. Okay, so this will give you 4 plus 3. Okay, I just want something to come. So assuming, I think I can. Assuming maybe you exhausted the line and you want to come down, you know what to do. Equal to will not be there. So it will be plus. Okay, then the next one will be 5 plus 2. Okay, then plus, okay, 6 plus 2. Okay, then plus the last term, which will be 7 plus 2. So obviously, as you add, the bracket will go. So this will give you 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which in effect will come and give you, therefore, the summation of what? R plus 2, okay, R starting from 0 and ending at what? 7, okay, will be equal to, so what did you get?
44.
Okay, so 44. Okay, if you are right, I'm also right. Okay, so with this, we know how to use the summation notation. Take notes how to use. And usually questions of this sort, you see it in what? In there's objective parts. And your calculator can do summation. Have you seen summation on your calculators? The sign. So if it's an objective question, please, I prefer you use, okay, the, what do you call it? The calculator. Otherwise, unless it's a complex, if it's simple, straight away, work it out, okay, like we've done this way. Okay, so now, okay, let's go and look at the relationship between U sub n and S sub n. But before that, quickly let me ask, are you all fine with the explanation on the summation, the sigma notation so far? Are you fine? Any
Yes, sir.
issues? Okay, great. So if you're all fine, then we can come and look
Sir.
at this. Yes, please.
Sir, please, I can't see the sum function on the calculator.
You can see it on your calculator. Okay, don't worry. I don't know the sort of calculator that you are using, but whatever be the case, even if you don't see it, you know how to do it manually. So
Yes,
how
I've
do
seen
it
it.
the only way? You've seen it?
Yes.
Okay, all right. Okay, so your calculator, obviously you didn't buy a full calculator. It is a brand new calculator that you bought. So you came with it manual. You read the manual. Okay. Usually, let me tell you, I think this is not the first time I'm saying this. For elective maths, if you read your manual, your calculator manual, and you really understand it, okay, about 80% of the question, you can use your calculator to do it. About 80%, if not, I mean, if I'm not exaggerating, okay, about 80%. So please, when you buy your calculator, read the manual. Even the Casio, the one, I think the ash one and the black one, the programming is somehow different. Okay, so until you read the manual, you wouldn't know how it is programmed. Sometimes if you might think you are feeding it with this information, so you expect a particular result, but because of the programming, your the feeding, okay, your inputs will be wrong. So definitely it will give you a wrong output. So study your calculator, especially the manual, to know how it is programmed and how you are supposed to deal with it. Okay, any sort of question when it comes to its programming. Okay, so now I think that was just by the way. So let's go to what we have here. Okay, so we are going to look at the relationship between U sub n. And what does U sub n represent when we talk of series and sequence? The notation U sub n.
It's a number of terms.
Really? Okay, you've tried. U sub n.
The n.
The n term. The number of terms is just the n. You remember? Okay, then what would be S sub n? What would that represent?
Sum of the first n terms.
N terms. Remember of the first lesson in format, I introduced you to all the notations and they are corresponding meanings. So at this point, it shouldn't be a problem now. Okay, so what we are going to do, okay, the relevance of what you knowing the relationship between the U sub n and the S sub n is that sometimes, okay, the question will come in such a way that you'll be given the S sub n formula. Okay, and you know that S sub n is for the sum of the first n terms. However, okay, you will be asked to find particular terms. And before you can find particular terms, you need the general term, which is U sub n, because it's U sub n that we use to find the first term, which is U sub 1, a particular term. The second term, which is U sub 2, a particular term. The third term, which is U sub 3. However, you are not given U sub n, you are given S sub n. How do I work with S sub n to find, okay, my U subs, my particular terms? And you can do that if you know, okay, this relationship that we have here. Indirectly, okay, we are going to prove this relationship together. Okay, the relationship between the U sub n and the S sub n. So we said the relationship is given by U sub n is equal to S sub n, okay, minus S sub n minus 1. Okay, so let's see if indeed this is true. Okay, so in every general sequence, we know that our terms will be given by U sub 1, U sub 2, U sub 3, okay, U sub 4. I think I can end here, ellipses. Is that clear? So, sorry, 2, it shouldn't be more than 3 dots. So let me take 1 off. Okay, all right. So this is what we have. So indirectly, we are looking at the proof. Okay, indirectly, which is not necessary. You just need to know the relationship and, okay, know how to use it, that's all. Now, if I'm looking for S sub 1, S sub 1 will be equal to U sub 1. Do you agree? Remember, I've said this before. You agree, right?
Yes.
Okay, what will be S sub 2? It will be the sum of the first two terms. So it will be U sub 1 plus U sub 2. Are we in agreement?
Yes.
Yes, sir.
Okay. All right. Very good. Okay. So now, can I say from, okay, so let's build our argument, you will know. Okay, S sub 3. Okay, you let me, I think I can still make that point. You people are sharp, so I shouldn't, okay, do things the usual way. Okay, so let's see. I know you will get it. Okay. All right. So in this case, can I say that my U sub 2, because I want to get whatever that I've had there in terms of U, because here U is made a subject. So can I say that my U sub 2 will be equal to, okay, S sub 2 minus U sub 1. Do you agree?
Yes, please.
Yes,
Okay.
please.
So now, can I equally say that my U sub 2 is equal to S sub 2 minus S sub 1?
Yes.
Yes.
Okay, obviously you can see that we said U sub 1 is the same as S sub 1. So it means whenever I see U sub 1, I can replace it, okay, by S sub 1. Please, are you following my professors? Those who didn't say
Yes,
yes.
sir.
Okay, very good. Now let's move on to S sub 3. Okay, S sub 3 will now be equal to U sub 1 plus U sub 2, okay, plus U sub 3. All correct. The sum of the first three terms.
Yes,
Yes,
please.
please.
Okay,
Yes.
but we also know that this will be equal to, okay, we know U sub 1 plus U sub 2 is the same as S sub 2. Do you agree?
Yes.
Okay, then plus U sub 3. So I can also confidently write that U sub 3 will be equal to S sub 3 minus S sub 2. Do you agree?
Yes, please.
Please, are you with me, my professors?
Yes, please.
Who is lost and wants me to come again? Some of them, they are waiting for this question. Who wants me to... Okay, so now this is what we have. From where? Please, I should come again from where?
The S sub 3.
S sub 3. Okay, S sub 3. What is the meaning of S sub 3? The sum of the first three terms. Am I right?
Yes, please.
So it will be first term plus second term plus third term. So first three terms. But you know, you said U sub 1 plus U sub 2. You have stated here that it's the same as S sub 2. So the whole of this, the first two terms here, I can replace it by S sub 2. Do you agree?
Yes, please.
Okay, then plus your U sub 3, which is there. Then now you come and make U sub 3 the subjects. So U sub 3 will be equal to S sub 3 minus S sub 2. Safa.
Yeah.
Okay, great. All right, so now one more, then we can, okay, do the general formula. So U sub 4, okay, will be equal to, so let me start with the S sub 4 rather. Okay, S sub 4 will be U sub 1 plus U sub 2 plus U sub 3 plus U sub 4. Do we agree?
Yes, sir.
Okay, very good. All right, okay, so now we are going to have, okay, U sub 1 plus U sub 2 plus U sub 3 is the same as S sub 3. Do you agree?
Yes, sir.
Then plus your U sub 4. So it means I can also say that my U sub 4, okay, will be equal to S sub 4 minus S sub 3. You agree?
Yes, sir.
Yes.
So now in general, okay, if I have U sub n, okay, this will be equal to, you can see that if this is 4, this is also 4. So it means if this is n, my sum for the first S will also be n. Is that clear? Check, look at the pattern. Okay,
Yes,
when
please.
if you study the pattern, this will come out. Okay, you have 2 here. If this is 2, your first S, the sum will be 2. If this is 3, the first S, the sum will be 3. So if this is N, the first S, the sum will be what? Will be N. Then minus. Okay, if this is 4, let's start from here. If this is 2, the second S, the sub is 1. If it is what? 3, the sub what? Or the sub here is 2. If it is what? 4, the sub for the second one, okay, S is 3. So it means that the second S sub is always 1 less than the N, the sub that we have here. So if this is N, it means I'm going to get S sub N minus 1. Is that clear?
Yes.
Okay,
Yes,
and obvious, should I come again, my professors? Or we are
Yes,
fine?
Come again.
Okay, all right, I heard your whisper. Okay, so now this is what we have. From where? Where exactly should I start from?
U sub n is equal to S sub n minus
Okay,
S sub.
so we are just looking at the pattern to generate the general formula. So let's start from the U sub 2. You said U sub 2 is equal to S sub 2 minus S sub 1. U sub 3 is equal to S sub 3 minus S sub 2. U sub 4 is equal to S sub 4 minus S sub 3. So if I have U sub n, you can see that if this is 4, let's start from here. If the sub for the U is 2, the first S, okay, S sub is the same as the number that we have here. If you come here, 3, the first S is the same 3. 4, the first S, the sub is also 4. It's the same as the sub for the U. However, let's come to, so it means if this is N, the S here, S sub will be N. As for that one, you agree, is that not it?
Yes, please.
Now let's come to the second one. All of them, it will be minus, minus. So you bring your minus. So it will be minus S sub something. But if the sub here is 2, the second S sub is 1. So it means it's 1 short of this. It's 1 less than this. Is that not it?
Yes, please.
Okay, if you come and do the 3, if this is 3, this is 2. So this is 1 less than this. Okay. Then if you come to the 4, if this is 4, this is 3. So it means this is also 1 less than this. So if this is N, okay, 1 less than N will be N minus 1. You agree?
Yes, please.
So it means the sub here will be N minus 1. So that's how come this formula is very valid. You get it?
Yes, please.
Okay, so now that we know this formula, and even, okay, we know how to prove that formula, let's look at how we can make use of, okay, that formula, the essence of this formula. So let's look at the following worked examples. Okay, quickly. Okay, all right, but before we come to the worked example, I think we can have our water break. Okay, when we come back, then we come and look at this. Okay, so let me pause. Okay, so you are welcome back from the water break. Now let's look at how best we can make use of the concept that I just walked you through. So let's look at our first worked example. Okay, given that S sub n is equal to n squared plus what? N. Find S sub n minus 1. Okay, then B, find the first 3 terms of the sequence. So it means indirectly you are supposed to generate the U sub n, because without the U sub n, you cannot find the first term, the second term, and the third term, which will be your first 3 terms. Then show that the sequence is linear. Okay, so let's see how best, okay, we are supposed to approach this question. So now, solution. Okay, it's already written, but you will write it. Okay, then questions are numbered because we want you to number your solution as such. Okay, so I have question 1, given. Okay, and I've been given my S sub n, and that is equal to n squared plus n. Okay, now A, what am I supposed to find? I need to find S sub n minus 1, and this will be equal to, okay, just like, remember I told you, the sequence, okay, usually works the same way as function works, because this is S sub n. It means your function depends on X, or your sum depends on N, I should say. So wherever you see if I'm looking for S sub 1, it means wherever I see n here, it will be what? 1. So if I'm looking at S sub n minus 1, then it means wherever I see n here, it is now what?
N minus.
N minus 1, as simple as that. So it means any n that I see there, I replace it with n minus 1. So it means if you know u sub n, you know u sub anything. If you know S sub n, you know S sub anything. So in this case, we know S sub n. So S sub n minus 1, I know. So that will give me n minus 1 all squared. Okay, then plus my n again, which is now n minus 1. Should I come again, or my point is well made?
Please come again.
Okay, all right. Okay, so let me explain from this perspective. If you have S sub n is equal to maybe n squared plus n. If you're asked to find S sub 1, what would this be equal to? Those who said I should come again, what would this be equal to?
1 squared plus 1.
1 squared plus 1. Okay, is that not it? And remember, I told you anything that you substitute for convenience sake, okay, put it in brackets. Okay, so 1 squared, okay, so 1 in bracket squared. So if you're asked to find S sub 2, what would that give you?
2 squared plus
2 squared then plus 2. So now, if you are asked to find S sub n minus 1, it means wherever you see n, it will now be n minus 1. So this n, if just as you substituted 1, 2, when you were looking for S sub 1 and S sub 2 respectively. Okay, you can see that here your new n is n minus 1. So wherever I see n here, it is n minus 1, but it is squared. Then plus this n is also n minus 1. Is it clear now?
Yes.
Okay, so now this will be equal to, okay, anytime you see bracket, what have you, expand, and usually most often than not, okay, you will get like terms to combine. So I know how to expand a binomial squared. If you can't do this one mentally, then you are supposed to do it as a rough work. So you are going to do n minus 1 multiplying n minus 1. Then you will do, this will give you n times n, which will give you n squared, n times minus 1 minus n minus n. So minus 1 times n minus n minus 1 times minus 1 plus 1. So that gives you n squared minus 2n plus 1. But those of us, okay, who are matured, in fact, all of us, we should be matured at this point, because I've said on countless occasions, I've taught you how to expand a binomial squared. So this will give you my first term squared, which is n squared. Okay, then minus twice the product of this and this. Okay, so that will give me product of this and this. N times 1 will give me n, then times 2. So that will give me 2n. Then plus my 1 squared. So that will be the expansion of this. Then plus, we come and remove the bracket here to do 1 times this, 1 times that. So you get n minus 1. All correct?
Yes, please.
Okay, so at this point after expansion, obviously you can see like terms. Okay, so when I'm combining my like term, that will be my last term. So I can draw my conclusion that therefore S sub n minus 1 will be equal to n squared, only one term in n squared, but 2 terms in n, minus 2n, then, okay, plus n, and that will give you minus n. Do you agree?
Yes.
And 1 plus 1 minus 1, that will go. So it means your S sub n minus 1 is equal to n squared minus n. Afa. Okay, Natalia. Prof. Natalia.
Mr. Hackman, please, I have a question.
Okay, now Prof. Natalia, I have an answer. So go ahead with yours.
Please, it's plus n minus 1. So why didn't you use the sign to expand the brackets?
Which one?
The plus into brackets n minus 1.
Mm-hmm.
Why didn't you use the sign to expand the brackets?
Which sign? The plus.
Yes, please.
That's what I use. So natural by there's plus 1 here. So it will be 1 times n, which is n, then 1 times minus 1, which will give you minus 1.
Okay, thank you.
You are welcome. All right, okay. So in this case, we are done with the first part, which is what? The A. Now let's go and look at the B. So when you are moving from one sub-question to another sub-question, you leave a line. So B, what are we supposed to do? We are supposed to find the first three terms. So it means we need to find U sub 1, U sub 2, U sub 3. All correct. But before I can find U sub 1, U sub 2, U sub 3, any particular term, I need to know the general term formula, which is U sub n. And here is the case, the question didn't give me direct information about U sub n. Okay, the information is about S sub n. But thankfully now I know there is a strong connection, a strong relationship between U sub n and S sub n. So I'm going to state that relationship and use it to generate my formula for U sub n. If we're given the sequence in terms of the numbers, then you study the pattern to determine whether it's an AP, a GP, and you know how to proceed to find your U sub n, okay, whether it is an AP or a GP. But in this case, I am not giving the sequence, only that I'm giving the sum of the first n terms of the sequence. So how do I get my U sub n, which is my general term? And remember we said we know that but U sub n, we know is equal to what? S sub n minus what? S sub n minus 1. Do you agree?
Yes.
Okay, so this implies that, now you are dealing with a relation. So you start with implication. Originally, this was an expression equal to, then the next one, you come down. So U sub n will be equal to S sub n, that is n squared plus n. Then minus S sub n minus 1, that is n squared minus n. Am I right? Should I come? Am I right?
No.
Okay, what is wrong? What is wrong?
And say,
I'm at all
Sir.
ears. Yes, please.
I say, please, I want to say that shouldn't it be n squared plus n minus a n squared plus n bracket close n bracket open n squared minus n bracket close.
Hey, you are saying a lot of things. I heard a lot of brackets close. So how many brackets are you closing? Okay, so it will be abnormal circumstance. I've told you. Okay, if you heeded to the advice, anytime you are substituting, for convenience sake, put it in brackets. Okay, for security reasons. So here you can see that you substituted for S sub n, which is the whole of this. So it's convenient. Put it in bracket. Only that some of us know if you don't put it in bracket here, there wouldn't be any issue. However, here, if you fail to put it in bracket, you are doomed. Because what you have before it is minus. And the minus should affect all the terms. So here, this should also be in bracket. So anytime you are substituting, take it from me. Mr. Ackman said, okay, that for convenience sake, let me put it in brackets. So that in a situation where the bracket is not necessary, if I put it in brackets, I don't have any issue. But where the bracket is necessary and I fail to put it in brackets, there will be an issue. So always I'll put it in brackets. Is my point well made?
Yes, please.
Okay, just as you saw here, I put the n minus 1 in bracket before I squared. Then the n substitution n minus 1, I put it in bracket. Here, I knew that the bracket here wouldn't be necessary. But because of their advice, I equally adhered to that advice. So in this case, I am going to get, okay, this to be equal to, I now come and remove my bracket. So I will get n squared plus n, then this will be minus times n squared. So that will give you minus n squared. Then minus times minus n. So it will be minus 1 times 1. So that will give you plus n. All correct. Prof. Karen.
Mr. Hartman, please,
Yeah,
why are you not subtracting this one from the n squared minus m, the bracket?
Why am I
all
not
brackets?
subtracting what?
-1.
This one.
Yes, from the n squared minus n all bracket, the last one.
Yeah. Why am I not subtracting 1 from this?
Yes, please.
Okay. Take notes. All right. Okay. Put your hand on your head and let me pray for you. Okay, don't mind me. Okay. All right. You know I've told you I like it. So this is it. Okay. You understood that you can see that this is different from what we have here. S sub n minus 1 is different from S sub n minus 1. Do you agree?
Yes.
This one, the -1 is affecting the sum. This one is the sum, then you subtract 1. You get it? So the two are not the same. With this one, I'm referring to the sum. I mean the sum, I should say. The sum here -1. But we've done that. Can't you see? We did S sub n minus 1, which gave us this. Do you agree?
Yes.
And S sub n was given. So now you know the formula. The formula is what? U sub n is equal to S sub n, which was given. So you substitute. Minus S sub 1, which you found. Or the question asks you to find, which is here. So you just substitute and now you come and remove the brackets and you are left with combining the like term. Prof. Karen Afa.
Yes, please.
Okay, yours is not that strong. Okay, or that's how you say your strong yes.
Yes, I understand.
Okay, very good. All right. So now we know we are going to get, now you combine like terms, n squared minus n squared, that will go. So it will be plus n. So that will give you, okay, 2n. Is my point well made? Okay. Now at this point, you can see that I didn't draw my conclusion with u sub n because I was not asked directly to find u sub n. I knew that I would need u sub n. So u sub n is basically, okay, what do you call it? Means to an end. So I'm now going to find the end in itself. So I am going to look at, so therefore, I was asked to find the first 3 terms. So I need to find u sub 1, u sub 2. So u sub 1 will be equal to 2 into 1, okay, which will give you, okay, 2. Is that clear?
Yes.
Yes.
Okay, so now that you know u sub n, you know u sub anything. Okay, so I can clear the whole of this. Okay, then go and continue there. We are almost done. Don't worry. If indeed you are following, then you are doing well. Okay, especially this being the first example. Okay, so now we are left with u sub 2. So u sub 2 will be equal to wherever you see n in u sub n. You are going to get what? Substitute 2. So it will be 2 into 2. Okay, which will give us what? 4. Okay, and the last one, which is the third term, u sub 3, will be equal to 2 into 3. And that will be equal to 6. Apa?
Yes, sir.
Okay, very good. So we are done with B. We are left with that of what? Of C. So now I'm going to write C. I leave a line, then you proceed. So C, we need to show that the sequence, okay, is was whenever you see show, okay, you know that you underline show. Your conclusion, something vital must be attached. It should be, okay, a little different from your usual conclusion when you are not asked to show. So show that the sequence is linear. So now the sequence we know, okay, the sequence, okay, so the sequence will be equal to, the sequence will be, our first term will be 2. Do you agree? The second term will be 4.
Please.
The third term will be 6, and your other terms. So between, please take note, between your ellipsis and the number here, there should be a comma. Okay, so you have the first. So this is the sequence. Now, how do you tell that a sequence is linear? Okay, it's an AP. What do you use in making that distinction or that determination? I'm waiting, my professors.
The common difference
there should be a common difference. Is that not it?
Yes, please.
As simple as that. So here you need to show that there exists a common difference. That's all. Okay, so now let's see. We are going to do, okay, indirectly. So let's do that and see whether this indeed is an AP. So as our rough work, remember where we started. So 4 minus 2 will give me 2. 6 minus 4 will also give me 2. So indeed, I have a common difference. So in this case, I'll write therefore, okay, the sequence is an AP, okay, it's linear. Let me use the word in there. Okay, as required. Remember, I've told you anytime you see show, you attach as required. But you don't just end there. You back it with the reasons. Okay, since, okay, there is a common difference of 2. Point well made. Is my point well made?
Yes, sir.
Okay, or you can say that the sequence is linear, okay, as required, okay, or a linear sequence, okay, as required, since D is equal to 2. We know D represents the common difference. Is that clear?
Yes, sir.
Okay, very good. So the first example, I think we are all fine. We should all be fine. If you are not fine, 70% at least you should be there. So let's see whether the next one will add the 30%. Okay, so we will move on to the second question. The sum of the first n terms of a sequence is n squared plus 5n for all integral values of n. Okay, so with this one, the all integral values of n, that's basically there to confuse you. Okay, if you've not seen that before, now you've seen it. Let me explain. Whenever we talk about integral values of n, then we are looking at integer values of n. So for all n being equal to 1, 2, 3, 4, okay, what have you? Is my point well made?
Yes, sir.
Okay, you saw that the previous one, the first one, this was not attached. Yes, please, my professor.
Please, can you come again?
Okay, I say anytime you read any math question, okay, and you come across for all integral values of n, okay, it means your n must assume integer values, whole number values. So your n cannot be fraction, that's all. So your n cannot be half, it cannot be minus 1/2, any fraction, or decimal. It should be whole numbers or integers. Is that clear? That is basically the meaning.
Yes, please.
Okay, so it means what you have here is true for, okay, what do you integer values of n. And indeed, if I give you s up n, okay, it's equal to maybe n squared. Let me use the same thing. Can you get s up 1.5? If I ask you to find the sum of the first 1.5 terms, will you be able to find it? You can't, because it should be the sum of either the first term, the second term, the first 2 terms. So it should either be 1, 2, 3, 4, 5, what have you. It cannot take decimal. So you can't find s of half or 0.5, s of 1.5, s of 2.5, no. Or 2.5, you can't. So that is the meaning. Point well made now.
Yes,
Okay, so indeed this will be valid for all integral values of n. So now let's go and look at the solution for this one as well. Don't worry at all. It is the same thing that we are going to do, only that the function for s sub n has changed. Okay, but whatever we'll do will be the same. So let's look at what 2, solution to question 2. What are we given? the sum of the first n terms of the sequence. You saw that the first one, you were giving this statement in math form, completely in math form. Okay, but again, here it's in the English form and we can extract it exactly in the math form. So it will be giving, okay, the sum of the first n terms is represented by S at n. Do you agree?
Yes.
And we are told that that is equal to, okay, n squared plus 5n. All correct, my professors?
Yes, please.
Okay, very good. So at this point, we are in a comfortable lead. Okay, so let's go and look at A. A, what are we supposed to find? The sum of the first n minus 1 term, so it will be S sub n minus 1. All correct? Okay, so which will be equal to, we know wherever we see n here, it is n minus 1, like we did in the first one. So you have, I'm substituting for n. So my new n is n minus 1. So there is a square. Okay, remember to put it in bracket. Then plus 5, your new n, your substitution, you put it in bracket, n minus 1. So now remember, after substitution, when you have brackets, remove brackets, combine like terms, if any. So we are going to expand this, which will give us n squared minus 2n, then plus 1. If you can remember, I've told you, a plus b all squared. We know this identity. A squared plus b, 2ab, then plus b squared. It's not equal to a squared plus b squared. You know this. You are informed too. As for this one, you should know. Then minus a minus b squared. The identity is a squared minus 2ab plus b squared. So that's what I use here to expand. So a is n, b is now 1. So a squared, n squared minus 2ab. 2 times this, then, okay, you get this, then b squared, 1 squared. Then plus, we come and expand this. That will give us 5n minus 5. Do you agree?
Yes.
Okay. And like I've told you, if you cannot expand this mentally, okay, just come and write it, its basic meaning, n minus 1 into n minus 1. Then, okay, expand and later import your results. You get the same result here. Okay, so this will be equal to, after expansion, like terms, only one term in s squared, so you write n squared. 2 terms in n, 3 minus 2n plus 5n, so that will give us plus 3n. All correct?
Yes, please.
Okay, then this 1 minus 5 will give us minus 4. Am I right?
Yes, please.
Very good. So what we have here is the S sub n minus 1. But you know, like I've told you, okay, from the beginning at this point when you were combining like terms, you could have drawn your conclusion there. But here I can still write therefore here. My conclusion is drawn. All correct. If you wrote given here, you can't write therefore. That one you are compelled to come and draw your conclusion. So take notes as well. Okay, so now A is gone. Let's look at B. Okay, B, we need to find the first 3 terms. So again, first 3 terms, particular terms. Do I know my formula for S, U sub n? No, I only know the formula for S sub n. That was given. I don't also know the sequence for me to get determine the type of sequence, and that will help me coin the formula for that of what the UN. So here, thankfully, Sn, there is a strong link, connection between Sn and UN. And what is that connection? The connection is that, so but I know my U sub n should be equal to my S sub n minus S sub n minus 1. Okay, I know my S sub n, that was directly given. And I found my S sub n minus 1. So if I substitute and simplify, that will give me the U sub n. That will help me find U sub 1, U sub 2, and U sub 3. So now what do? I can choose not to write implication and just come and write equal to. It means that this is still here. Okay, what is equal to this? What is above here? And here is here. So now what do I have? S sub n, I go and substitute. So S sub n, I was given, or we were given this. So remember I said anytime you are substituting for convenience and safety reason, put it in brackets. Then, oh, sorry, yeah, that's it, then plus or minus, sorry, S sub n minus 1. What did we get? This. Okay, so 3 terms, you put everything in bracket. N squared plus what? 3n minus 4. Is my point well made, my professors?
Yes, please.
Yes,
Great.
sir.
Okay, who wants me to come again? Yeah, for the first time. Okay, thank God. All right, so now let's move on. The next step is to remove brackets and combine like terms. Here is 1 times the whole of this, so that will give you 1 times any number is the number itself. Okay, then minus 1 times this, so that will give you minus n squared. This time, this will give you minus 3n. This time, this will give you plus 4. Okay, so n squared and minus n squared, that will go. I will get 5n minus 3n, and that will give me 2n. Then I will get plus 4. All correct?
Yes,
I
please.
don't draw my conclusion for UN because UN I was not asked directly to find. It's question that you are asked to directly to find that you conclude, either with therefore or hence. Hence when you have hence in the question. Okay, but here you were not asked to find UN. So whatever you were asked to find, use up 1 first term, use up 2 second term, that's what we are going to find. So therefore, okay, my use up, remember use up n is this. Okay, so my use up 1 will be equal to 2 into 1 plus 4. And that will be equal to 2 plus 4, which is equal to 6. Do you agree? Okay, and the second u will be use up 2. And that will be equal to wherever I see n in use up n, it is 2. So it will be 2 into 2 plus 4. That gives us what? 4 plus 4. And that is equal to 8. And the last one, and okay, use up 3. Okay, we know will be equal to 2 into 3 plus 4. Okay, which will be equal to 6 plus 4. Okay, which is equal to 10. So you found your first 3 terms. All correct?
Yes, please.
Okay, so here we need to show that the sequence, okay, again, is what's linear. The sequence is linear. So you know what to do. So let's go and see. So you are looking at C. You leave a line before you come to C. Then C, the sequence, what will be the sequence? So the sequence will be your first term is 6, your second term is 8, your third term is 10. Okay, then your ellipsis. Is that clear? So for us to determine linear, as someone said, okay, we need to show that there exists a common difference between 2 consecutive terms. And here you have 3 terms. So you do this consecutive term difference, and that will be it. And I said you can do that as your rough work. Or, okay, we can write this way. So let me go and have, okay, D, I can also write, okay, I think let me go by the usual way. So I'm going to get 8 minus 6, and that will give us 2. Okay, 10 minus 8, that will also give us 2. So there exists a common difference. Okay, so in this case, you know the conclusion. You draw the same conclusion as the other one. So therefore, okay, the sequence is linear. Okay, as required. Okay, and when you reach show, I've told you underline as required. Okay, then you attach your resistance. Okay, D is equal to 2. And if this happens to be your rough work, don't forget to strike it out. Point well made.
Yes.
Yes, sir.
Very good. Okay, you are doing well. Keep it up. So now at this point, okay, we are going to look at the next one. Okay, so this I will just. Yes, please, my professor. Should I go back?
Yes, please.
Okay, capture quickly, then because
Please.
you are going to have a class exercise. Usually, if I give you assignments, most of you, but some of you don't do it. I want everyone to participate for me to measure your level of understanding. So this one is gone. Let's go and look at question 3. It's similar to what we have done. Okay, here I will help you up to a point. Okay, and that will be it. Okay, so quickly, this question, we've solved it, and you know that we've solved it indirectly. Only one information that I need to give you, and that will be it. Okay, so question 3. What are we giving? The sum of the first n terms of a sequence. So you've been given S at n is equal to n into n plus 5. Okay, all right. So please, okay, what notation is this? I've introduced you to this, especially when I taught you binary operation, especially those that I taught binary operation, as you say. Okay, this symbol, I've introduced you to that. What is the name of this? I introduced you to this symbol as well. Okay, who will tell me the meaning of what each of these symbols? If you know one, you can put up your hand and mention the one that you know. What is looking like a turned upside down? Wow. Hey, guess forgettance. Okay, all right. Okay, so Prof. Amma.
Sir, please, I'm trying.
Okay.
Sir, please, the A which is turned upside down, I think it is if and only if.
Okay, you are trying. Okay, so that is if and only if. So what about this one?
I've not seen it before.
You don't know this one, IFF.
The IFF is if and only if.
Okay, so indirectly I've shut down. You get it? Oh,
Yes.
this one is for all. So take note, for all those who have forgotten. So you can see that here we are going to read this one as for all, okay, integral values of x. The other one for all was written in words. We didn't use the notation. Now I'm using the notation so that, okay, I've told you questions now sound. So we just play with notations and some basic stuff just to confuse you. So when you see this, this one, what is this? Is this the usual question that I solve? Just to confuse you, and it's for all. And this one, remember I said there exists. So take notes. I introduced you to this when we were doing, what do you call it? I should say closure. There exist some elements which do not belong to the table, which do not belong to the set. We did all that. Okay, but that was just by the way. Okay, so this question is the same as question 2. If let's go back and see. Okay, only that the question 2 here is the expanded version of question 3. Can you see that? So this is the factorized version of question 2. And question 2 is the expanded version of question 3. Is my point well made?
Yes, sir.
Okay, so whenever, this is my point, whenever the sum of the first n term comes in the factorized form, take it to your comfort zone, expand first before you go and carry out your substitution for your S at n minus 1. That's my point. So here, given this, you know it will be convenient for you to work with the expanded version. So you expand and that will give you n squared plus 5n. Then this one takes us back to, okay, the question 2. So the solution from here going will be the same as that of what? The question 2. Point well made. Otherwise, the reason why, otherwise, when you are asked to find S at n minus 1, okay, if you want to substitute here directly, you can. And that will give you n minus 1 in brackets. Okay, then you in brackets n minus 1. N minus 1 must also be in brackets here too, because before your 5. And you can see a lot of brackets there. You get it? So it makes your work a little busy. So now what do? Come and remove this bracket and later remove the outer bracket, obviously. But if you remove the bracket from the beginning, now when you substitute, you take it to your comfort zone and your work becomes very easy. My professors, am I clear? Is the advice well taken?
Yes, sir.
Okay, very good. So on that note, okay, you should be able to do this one for me as your assignments. Okay, so do this one as your assignments. Okay, and this is supposed to be your take notes of this particular question. Take notes of this particular question. Remember, it is in what? In green. Okay, so when I ask you to take notes, those of you, you know, any question in green, you are likely to see it in your class test. So this is going to be your class assignment. How many students do I have here? You are all taking parts. Okay, I have about 28 students. So you are all taking part. Please take notes. Is my point well made, my professors?
Yes.
Okay, so at this point, I'm bringing the lesson to a close. Yeah, okay, so now, okay, that is going to be it. Okay, today we've done the summation notation, okay, which is the same as the sigma notation. And we've looked at the relationship between, okay, the general term and the sum of the first n terms of any sequence. Okay, and that works for both AP and GP. The relationship will work for AP and GP. So it's a general relationship between U sub n and S sub n. And we said that U sub n will always be equal to S sub n minus S sub n minus 1, where S sub n minus 1 is your sub. Okay, the whole of the n minus 1 is your sub. So please take note. Okay, so thank you for your contribution, for asking questions. Okay, and letting me know when you are not. Okay.
Sir, please, may you send the assignment to the group?
Yes, so all assignments must be sent to the group, you know. Okay, this. If you have not created that platform, please go and create it. You know I've given you the instruction. I will post it, okay, to the platform for those of you who have missed that. Okay, so please take note. That is how you submit. You just capture your picture and you send it. And please, okay, Natalia, okay, and to the rest of you, when you are sending your pictures, take notes. You have to send your picture in such a way that I don't have to rotate before I mark. So when you capture, let it be in the portrait orientation. Immediately you send it and you know I'm supposed to, okay, rotate before, then you have to do that rotation, then you send it to me. Is that clear? So because that is your first time, so I pardon you, I did the rotation and I marked for you. Subsequently, I won't do that. Okay, so on that note, thank you very much for making the class a success. God bless us all.